All right. Well, good morning. And that was a very, very interesting presentation about something weather related, hurricanes. But today I'm going to bring you back to Middle Tennessee and talk a little bit more about the weather that we see. And I think what Cliff and Laura asked me to talk about was, things to look for, things to see when we're, expecting bad weather, what to report, what is dangerous, what isn't dangerous. So I put a few slides together. Actually, I put several slides together, and it just, cut me off if you're done with me, whatever. And I didn't send my presentation ahead of time because I have some video and I'm hoping the videos work. But we'll go through some of the lookalikes and that kind of stuff. And maybe we can even go into some basic radar things. So first off, let's see, let me get that. There we go. All right. Supercell thunderstorms. This is what's causing the big time severe weather. So when you think about the March 2nd, March 3rd tornadoes, that was a supercell thunderstorm. You're in Williamson County, so that storm that produced that hail damage in the afternoon hours or overnight in Spring Hill, that large hail, that was a supercell thunderstorm. So pretty much supercell thunderstorms are those big time, beautiful thunderstorms, if we could see them and weren't rain wrapped, out in the Great Plains. With supercells, the whole storm is rotating. So when you see on your radar, so say you have GR2 or GR3, or you're watching the news and you see those little circle things, and maybe the TV meteorologist calls them mesos. The reason why we don't issue tornado warnings for every single meso is because that's just showing you where the supercell is. It's showing you that there is broad rotation. So every supercell thunderstorm has broad rotation. It's all rotating already, but usually it's at the mid levels is where it's rotating. So that's why you see those mesos a lot of times in the algorithms on the radar, and why we kind of just we don't ignore them, but it's like, okay, yeah, we got it. We don't necessarily need them to know that it's a strong to severe thunderstorm. These most of the time move southwest to northeast, not all the time. We saw on March 2nd, March 3rd of last year, that thing moved due east right along I-40. So, but most of the time they move to the northeast. So if you were out in the Great Plains, you had a perfect view. This is your textbook look at a supercell thunderstorm. It's perfect, right? This is looking west-northwest into the supercell. So you can see a few of the things that you can pick out and that maybe we can see in Middle Tennessee, overshooting top. We can see that when the thunderstorm is greater than 20 miles away, or the anvil. The whole thunderstorm cloud is called a cumulonimbus cloud. There's a flanking line that's south of the storm. That's kind of like a stair step down. And then the important parts are down here at the surface, where you have the rain-free base where it's not raining, where you have the rain and hail, the downdraft part of it, and then the action area. So like I said, that updraft, the whole supercell is rotating down towards the northeastern part of the storm. That's where you have the hail, rain, downdraft, and you're going to look in the action area. So between where it's not raining and where it is raining, you're looking in the middle. That is the action area. Now, I'll tell you, in Middle Tennessee, it's really hard to see this stuff sometimes. A lot of times we have trees, we have terrain. A lot of our storms are rain wrapped. And a lot of 47% of our tornadoes occur at night when it's dark. So you're not going to see any of this. So if you think about it and you think, okay, 53% of the tornadoes that occur in Middle Tennessee occur when it's light out. Okay, so that's maybe 1 out of every 2 tornadoes, right? And then you have to reduce it even more by, the tornadoes that are rain wrapped. And I would say greater than half of those are probably rain wrapped tornadoes. And then you have to reduce it even more because of trees and terrain. So your chances of really seeing a tornado are very, very, very small in Middle Tennessee. We had that little tornado over in Cookeville the other day. We had reports of funnels all across, but I think the terrain kind of got to that and stretched the funnel a little bit and was able to hit the ground over in Pleasant Hill. And in those cases, yeah, you can see that, but those are pretty few and far between. So here's your updraft, nothing going on below the cloud base. That is just the warm air rising. And if it's a supercell, it's rotating. And then the downdraft, where you have the wind, rain, and hail coming down. Gravity is no match for it, and it comes down. And in this picture, you can actually see the updraft as well. So a wall cloud. Now, this is part of that action area. It's a very, very, very small part of the cloud base that lowers down. And the good rule of thumb is we have a lot of lookalikes of what people think are wall clouds, and then aren't necessarily wall clouds. Wall clouds, a good rule of thumb is they slope, right? They're always at an angle. They're going to always, I would say 99% of the time, slope down and point towards the downdraft. They're going to slope down. So see how this in this picture slopes down? It's going to point to the rain, the downdraft. And that's where tornadoes will form from. Not all the time, but that's where, if you have a big supercell classic storm, that's where they're going to form from. So here is a wall cloud right here. Not as defined as the last picture, right? And it's all relative. It's just that lowering of that cloud base coming down. And you can see it's in the action area. Here's the rain. Here's where it's not raining. In the middle is where the wall cloud is. Here's another one, pretty close. You can see where that wall cloud is. See that it's sloping down, pointing towards the rain. So now a wall cloud does not always mean tornado. In fact, you can have wall clouds all day long and they not produce anything. When are they dangerous? Well, when they rotate. And that's going to be a big theme in my presentation. When it's spinning, when it's rotating, that means it can be dangerous. If it has persistent motion or you see rising motion, so new clouds forming into the wall cloud, that's dangerous. So hopefully you can see this video. And it's not going to be anything that sticks out like a sore thumb sometimes. They're not going to be rotating as rapidly as tornadoes or funnel clouds. It's usually going to be a pretty slow rotation. In this one, you can't even see it rotating. But that is a dangerous wall cloud. Nice low hanging of the cloud base. Now, what gets confused a lot of times is a shelf cloud. So a shelf cloud is pretty much a cloud that covers the majority of the sky. So a wall cloud is going to be very, very small in comparison. Maybe a shelf cloud is going to be what a wall cloud would be about like 5 to 10% of the size of a shelf cloud. Does that make sense? Shelf cloud is an indicator of strong straight line winds. This is going to be on the edge of storms as they blow in. You're going to see them with squall lines, the line of storms that are coming in. And even with supercells, you can see a shelf cloud. It depends on what part of the supercell you are impacting. So here's the difference. The best rule of thumb with this is a shelf cloud is going to slope to where it's not raining. A wall cloud is going to slope to where it is raining. And you can see that the wall cloud is much smaller than the shelf cloud. Okay, funnel cloud. This is typically formed a rotating wall cloud, but not always. A funnel cloud is where it is rotating violently. So very, very strong rotation, but there's nothing touching the ground. Okay. So if you report to the office, I've got a funnel. Well, every forecaster in that operations is thinking that it's not a tornado and it's not on the ground, that it's just a funnel cloud. So make sure that you are good with what you report, because if you say, hey, I got a funnel, we're immediately thinking it's not a tornado, it's not on the ground, because that's a funnel cloud. Once you start seeing debris and things getting picked up into that funnel, it's immediately a tornado. So the picture on the right, you can see that it's picking up dust, dirt, debris. That is a tornado. So funnel clouds usually don't last very long. They either do something or they spin a little bit and then they dissipate. So you're probably not going to have a funnel cloud that persists for more than like 10, 15 minutes. That would be pretty rare, I think. And then, of course, tornado. It can be in all different shapes and sizes. The picture on the left, pretty evident that that's a tornado. It's a violently rotating column of air in contact with the ground. All right. Tornadoes don't always look like that, and that's probably a good thing, right? The picture on the right over here is a dissipating tornado. This is the dissipating stage, where you have, the funnel is getting all kinds of contorted, but you can still see on the ground, it's picking up dirt and debris. That is still a tornado. And then, of course, scud clouds. And I love describing scud clouds as it's the type of picture where my mom would tag me on Facebook and say, Chrissy, that's a tornado. Chrissy, did you see this tornado? It's one of those too good to be true, looks kind of fishy. I wonder if that's photoshopped kind of thing. All right. So this picture is one. You're not going to have 4 tornadoes together. This is what we call scud clouds, scary looking clouds. A lot of times with these scud clouds, we have a lot of moisture, especially just above the surface. So you can see that this is up on the little mountain there. A lot of moisture is around. Those are just clouds that are extending down. If it's not rotating, if it's not spinning, it's not dangerous. Okay. So for it to be a tornado, it must be spinning. For it to be a funnel cloud, it must be spinning. For it to be dangerous, it must be spinning. If it's not spinning, it's not winning. I don't know. Trying to think of some funny phrase. So nighttime spotting is another one where, it's super dangerous. We tell people just don't even bother, especially around here in Middle Tennessee, because you're anticipating trying to figure out what you're seeing
video again, Nathan.
Based on like
it's pretty decent. So if you want to stop.
See per second data.
You keep forgetting about it.
Yes.
We're almost at 500 millibars.
Cool. What are the set rates like?
170. Not the best set rate, but we're 37 kilometers away from it.
Oh my gosh, that's
Oh my god.
So what was that? Can you confidently tell me what that was? You had what, a half a second to determine? Was that a tornado on the ground? Could that have been part of the downdraft? Was that a shelf cloud? Was that, I don't know, a scud cloud? Was it rotating? There's a lot of questions you got to ask yourself before you can report that as a tornado. So when we take the still image of that, man, that looks pretty scary, right? But is it a tornado? Well, this happened to be what we call like a scud bomb. So scud clouds that come down and it looks pretty wide that comes down, part of the downburst. And we had one of these in Murfreesboro several summers ago. And man, after having the Good Friday tornado, it probably scared the bejesus out of a lot of people in Murfreesboro. And you can see how they're two very similar. But in the daytime, it's easy to see, hey, that's not rotating, that's not spinning, that's not dangerous. At nighttime, you see something like that and you're like, oh my gosh, that's got to be a tornado. And no. So hopefully that helps with that, spotting stuff. All right, so we're going to talk a little bit about what you really see in this picture. Right here where the black arrow is, and you have the dark area, is that a tornado? No, that's not a tornado. That is the downdraft. So that's where the rain, the straight line winds, and hail are. Do you have a tornado? Well, you look in the action area where it's not raining, where it is raining, look in the middle, and there you go. You have a little wall cloud right there and a tornado. So make sure you look in the correct part of the storm. Here's another one.
Like a tornado. Oh.
All right. Was that a tornado? Well, you can't really tell, right? But the one thing you can report is that was a power flash. And when we have power flashes, we know two things. Either we have a tornado or we have incredibly strong straight line winds where the power lines are arcing, or a power pole was knocked down. So either way, both of those need to get reported, or that event needs to get reported to the Weather Service, and then we can base on the location, base it on radar to what it would most likely be, whether it's a tornado or straight line winds. Here's another one. Can you confidently say what this is? I would hope not. You can't really see. It was actually an EF4 tornado that was rain wrapped. Here's another one where my mom would have totally tagged me in this on Facebook or sent it to me and said, Chrissy, oh my gosh, did you see this octopus tornado? If it looks strange or stupid or just fake, it probably is a fake. Regardless, if you don't know and you're not comfortable with, it still, worries you, send it to the office. Send it through email to me, something like that, and we can at least investigate it for you. Here's another one. Is this a tornado? Well, you see debris, right? So if you see debris, plus you see a bunch of storm chasers taking their photos with it, that's another way how you know. But yeah, you see the debris picking up from the ground, that is a tornado. This feature right here, you see the difference, right? So this is a shelf cloud. It covers the majority of the sky. Whereas if it was a wall cloud, it would just be this small little area. All right, so that is the difference. Here's another one where you have wall cloud or shelf cloud. You actually have both in this video. So it was a trick question. Right here is your shelf cloud that's developing, and your wall cloud's going to develop closer to the ground. So you see it? And then it gets undercut by the downdraft. This is another one where people see this and they're like, oh, that's obviously a tornado, right? But remember, one of those things that I said, that it has to be spinning. If it's not spinning, it's not dangerous. Well, in this case, this actually, I believe, was in East Tennessee. I think this was on a Weather Channel calendar, gosh, probably like 20 years ago that I had when I was a kid, maybe longer, 25 years ago. This is actually smoke from a fire. and they did a morning burn, and they didn't wait until the inversion, so where the temperatures are warmer just above the surface. And so it kept the smoke from dispersing, and it kept the smoke right there at that level. And so it was going up, not dispersing, and it made it look like a tornado storm. Here's another one. This was over in Cookeville, summer of 2015, 2016, one of those. And so she zoomed in on the wall cloud. You can see it slowly rotating, right? Slowly rotating. And then you start seeing the funnel. Once you see it on the ground, you know, filling in, it's dark, that is a tornado on the ground. We were very lucky on this day that one of the emergency managers, who was very well trained in storm spotting, it was very close to his neighborhood, and he happened to be out there watching it, and he saw it touch the ground and called us, and we were able to get the tornado warning out before it hit a bigger neighborhood close to I-40. So we were very, very lucky that, you know, this person was at the right place at the right time. But you can see, you know, the wall cloud still rotating, and you can see the tornado. It's not very well defined. This is kind of what we call the quick spin up weak tornadoes. I believe that this was rated EF0, maybe a low end EF1. And you can definitely tell it looks like it's maybe skipping. And instead of it skipping per se, it's probably, you know, developing and then dissipating, developing, dissipating. And now it's starting to hit some stuff, and so it's filling in a lot more. So even though it's not, looks like it's attached, it is attached. So if it's rotating at the ground, rotating at the cloud base, it is a tornado. All right. So positioning is really important. And regardless of whether you're going to get outside your home or not to storm spot, it's still important to know that if you're in your home, you know, where the storm's going to be in relation to your home, right? So this is what a supercell would look like on radar. In the black area, that's going to be the heavy rain, hail, and damaging straight line winds. You see the hook that's in the red circle. That's the action area. That's where you're going to find the wall cloud, funnel cloud, tornado. So that's a classic supercell on radar. In our area, most of these move, you know, like I said, southwest to northeast. So if you're north of the storm, are you in a safe place? Yes. Are you going to see anything? No. You're going to see a lot of rain, but you're not going to be able to see any kind of rotation. All right. What if you're due east of the storm? Are you in a safe place? Probably not the safest, but you know, as long as it's moving northeast, you're okay. But remember, in tornadoes, a lot of times they move a little right of the mean flow. So if the mean flow is moving northeast, they may move a little east northeast. So it's going to get really hairy if you're due east. That may be what you're seeing. A good rule of thumb is if the tornado looks like it's getting bigger, wider, it's probably not. It's probably just getting closer to you. I read something yesterday was the 23rd anniversary of the Nashville tornado. And it was the 23rd tornado of Tennessee's only F5 tornado that was down in Wayne County, Lawrence County, Giles, Murray. And I guess the guy that was videotaping it, I saw that he was in did an interview with Davis Nolan. And the guy said, yeah, we were videotaping it. And the tornado just kept getting wider and wider and wider. And I kind of chuckled to myself and I was like, yeah, because the tornado was getting closer, closer, closer. So keep that in the back of your mind if you ever do see one of these. All right. And then if you're southeast of a storm, is this a good place? Absolutely. This is where you want to be. This is your safe place because you're going to have a good view to the west-northwest. You're in a safe place if the storm moves northeast or even east. And if it gets too close to you, you can move south too. And so this may be what it kind of looks like right here. All right. So how to report severe weather. I love this one. There's a wise man who knows where courage ends and stupidity begins. Never a good reason to get that close or follow it. So what do we need to know? We need to know the what, when, and where. What we don't need to know, we don't necessarily need to know, who you are, your whole life story, how long you've been storm spotting, where you got your certification, what your storm spotter number is. We don't even give those out anymore. We don't need to know any of that. We just need to know what, when, and where. All right. And MTRS does a fantastic job getting that information to us. And, Laura, Tom, Elizabeth, that just fantastic ways to get that information to us. And we do appreciate that. So, the what, when, and where. What type of severe weather is occurring? When did it occur? And where? So reporting locations, make sure it's the location of where it happened, not necessarily where you are. Street names are fantastic. Addresses, anything that we can Google Maps search, closest business, that's fantastic. GPS coordinates are great, but a lot of times we're oh, okay, is it minutes or is it in degrees? So an address is usually plenty good on that. What we need reports of, of course, funnel clouds and tornadoes, any kind of damage, high winds, trees down, high winds. When I say high winds, we're in Middle Tennessee. And so our winds aren't very windy. And so when we get those days of where we get high winds of 30, 40 miles per hour, we don't need those reports. It's windy, yeah, but we don't need those reports. What we do need is damage for high winds. And usually you're not going to get damage until you get about 65 miles per hour or higher. That's a generally good rule of thumb. If you're going to have, outbuilding, roof damage to a house, you're looking at more, 70, 75. If you have trees snapped, you're looking at closer to 80, 85. As far as hail, pretty much dime, nickel size hail or greater. We don't really record it until it gets to quarters. So 1 inch in diameter or higher. And then ice and snow, that's just kind of bonus. Hopefully we don't have to do that anymore this season. No, we won't, I promise. So hail, make sure you report the largest size you see. I think the common misperception is, majority rules. Well, think about it this way. What's going to cause the most damage? Well, the largest hailstone that you see. So make sure it's the largest size. If you can measure it, great. If you take a picture of it, make sure it has an object that you compared the size to. So like this guy, I don't know how big, he might have tiny hands. I don't know. That's the way to do it. And a wind gust, we are terrible at estimating wind speeds. And I think it's because maybe we live in an area that's not very windy. And so when it gets really blowing, we're like, oh my gosh, it's got to be the worst ever. So when people send in what they're estimating, if it's not measured by equipment or properly sighted equipment, we typically, divided by 2 or divided by 1.5. That is usually what the wind speed estimates are based on the naked eye. And then, of course, flash flood. So in case you don't have your ham radio equipment or easily accessible to report, you can always call that 1-800 number, 1-800-267-8144. We're also on Facebook and Twitter if you're also on there. 1-800-267-8144.
All right. That it? Oh, you
Yeah,
got
I was just let's see. Yeah, that is my contact information. So if you need anything, just let me know.